So now I'm going to start with the Froth flotation method. It's a very interesting method as well, and it is used for sulfide ores only. Why it is used for sulfide ore, we'll discuss. So we have to understand firstly what the principle is. Principle is that differential wetting of ore with oil and gangue with water. That means the ore that we are using, the impure ore, this is concentration of ore going on, cleaning of ore is going on. So your ore has the impurities. So the ore will be covered with oil. So it is wetted with oil, and the gangue, that is the impurity, is more attractive, is attracting more and more of water. So it will be wetted with water. So because the ore is attracted towards oil more, and the water and the gangue get attracted towards the water more, as a result they can be separated easily. So it is used for sulfide ore. We use some collectors. By the name it is clear what's the role of collectors. Collectors will go in the aqueous solution, will collect the sulfide ore and will bring it with himself. So collectors they work in a group, they work as a team. The first member in the team is sodium ethyl xanthate. That's the formula of sodium ethyl xanthate. This formula is not there in the NCERT, but I need this formula to explain you the basic grassroots principle involved in this process. So I've given you the formula. So CH3, CH2O, CH2 minus. This CH2 is C double bond S, single bond S, just like COO minus. Just like we write now COO minus, it is CSS minus, I can say. Again, this is a hydrophobic tail, so I'm representing like this, and this CS minus, OCS minus, I'm representing as XN minus. So just like a soap or a detergent, we have a hydrophilic head which is negatively charged. Negative positive charges are hydrophilic, water loving, and this is the hydrophobic tail. Hydrocarbon chain is hydrophobic tail. The second part in the collector is pine oil or fatty acid. Apart from that, we have froth stabilizers that are cresol or aniline. Now, what is a froth? If you stir water a lot with your hand itself, let's say add some detergent there and stir with your hand, some bubbles, group of bubbles will be formed on the surface. That group of bubbles, that thing is called froth. So if you have had a very good coffee recently, nowadays on the online net also some Dalgona coffee, or in normal day-to-day life we call it as a beating coffee or brew coffee we have, that has some bubbles on the top. That bubble is called the froth. So to stabilize that froth, so that the froth do not disappear, we need cresol and aniline. So cresol and aniline will make the froth stable, so the froth will be formed and will stay there for some time. These are the stabilizers used. Directly one question they asked from here also, which are the stabilizers used in the Froth flotation method? Froth stabilizers used are cresol and aniline. So here, what is the major thing that you have to understand? You have to understand here one thing you need from surface chemistry chapter, that is common ion adsorption. Not common ion effect, huh? Not the common ion effect, it is common ion adsorption. What does it mean? Simple here. If you have a surface of a compound, right? And if the compound get a chance to absorb something on the surface, to stick something on the surface, he prefers the common ion. So you might have read that AgI ore is there, and if Ki is added, then I minus get absorbed over it. If you have AgI ore, AgNO3 is added, Ag plus will come and get absorbed over the surface. So when you have AgI ore, either the I minus will absorb preferably, or Ag plus will absorb. The other ions are not easily absorbed on the surface of a compound. So in the same way, when we use sodium ethyl xanthate, which is a sulfide ion on the hydrophilic head, it has a sulfide ion there, it simply means that it will stick to the sulfide ore. That is why it is used for only sulfide ore. Let's take one example. So if for example I have ZNS. So I've written some ores on the top. ZNS is zinc blende or sclerite. Understand the difference? Many people do not know why the two different names are given. Zinc blende you read in solid state chapter. It has a CCP lattice, cubic closed packing, or FCC we can say. Sclerite, ZNS formula is same, but sclerite has HCP lattice. No need to go in detail, but that's the difference. So both are ZNS. Cu2S is known as copper glans. CuFeS2 is known as copper pyrites. Apart from that, you might have heard PBS is galena. Galena, galena, PBS. These are the sulfide ores we have. So let us take ZNS. Now ZNS is there. Here in this container, I added water. In the water, I added crushed ore. Understand, the ores are always crushed first. Why? To expose more and more surface area. I hope this part is clear. So that more and more ores can come in contact with the reagent you are going to add. So we crush the ore, we add it here, we add oil. Which oil? Pine oil usually we add. We can add other oils also, like eucalyptus oil is also there, but all those are outside NCERT. So stick to the NCERT part. Pine oil is enough. Xanthate, that is this sodium methyl xanthate I have added, and air. So it is added usually from here, from this direction it is added, but for simplicity we just add it here. Then what we do, we have this beater. So this will rotate, and this will, it's just like you do in your home also. We have a beater like mixer grinder we have. So what he will do, he will stir the whole mixture properly, so everything will mix with each other. And as we know, the water will get attracted towards the gangue. The oil will cover up the ore. That is the main thing happening. But the scenario here is this. This is the ore. Let us say one big ore I have taken out, I magnified it. What will happen? In this same medium, you have xanthate also. Xanthate has a sulfide ion. So he will get absorbed over the surface of ZnS. Which principle is this? Common ion adsorption. Okay, भाई साहब? Common ion adsorption. What does it mean? Nothing here. ZnS was there. So xanthate had sulfide as the common ion. So bhaiya, sulfide will get stuck over there. So what happens now? This xanthate got stuck over the ore properly. Problem with the xanthate is that he has a hydrophilic head which loves water, which want to stay in water. It has a hydrophobic tail, hydrophobic, water hating, water fearful tail, and this tail want to be away from water. Now, where in this world is it possible that he remains half inside the water also, half outside the water also? It is possible only in one case, when he goes up to the surface. So when you beat it properly, grind it like this, again and again you are mixing it, a lot of froth will be made on the surface, and in that froth who will go? This xanthate will go, sodium ethyl xanthate, basically ethyl xanthate will go up. But because sodium ethyl xanthate or xanthate here is stuck on the surface of ZnS, Na plus will remain down, that's not a problem. Xn minus is stuck on the surface of ZnS, along with him he will take ZnS also on the top here. So here you will get the froth, and in this froth you will have the ore also. Why this froth formed up here? Because hydrophobic end wanted to be in the air, hydrophilic wanted to be in the water, so here they came on the surface. But along with them, because they are stuck to ZnS, why they are stuck to ZnS? Because of common ion adsorption, so ZnS also came up. So what we do, this froth is dried to obtain ore. So this is how the froth flotation method is carried out. What's the role of oil here? Nothing here, just oil makes one thing sure, that this ZnS get covered with the oil, so it is not attracted by water much. On the other hand, the gangue get mixed up with water and will remain down. So the froth has more and more of ore, because it is not in much contact with the water. It is kind of oil coating is there, so water cannot touch it. Just like you dip your hand in the oil and then try to pour water over it, so you will understand water cannot wet your hand anymore. But gangue got mixed in water and stayed down. So here this is what the froth flotation looks like. So I think this whole idea is clear, and you understood why this structure I made, to make you understand. If your common ion adsorption topic is good in surface chemistry chapter, even if it is not good, now I just now revised that part also, so you can understand both simultaneously as well. Apart from this, one major thing that is asked in the NEET examination is the depressant. So imagine sometimes you are very unlucky. Sometimes what happens? What happens is that, let us say, PBS ZnS combination is there. That means the impurity as well as the ore both are sulfide. Then what will happen? Then there is a competition. Xanthate will stick on both the surfaces. Froth will be formed. Froth will contain both of them. But this is not a good idea. What we should do? We should depress someone. We should change someone in such a way that only one person can stay in the solution as a sulfide. The other person should change. So what we use? We use NaCN as depressant. How? Simple here. What will happen? With PBS, NaCN does not react. Why? I think you are very much expert in the D and F block. You will understand Pb is from P block element. He does not like forming complex compounds. Zinc is from D block element. He has a tendency of forming complex compound. And Cn minus is a ligand. He will love to form complex compound, but Pb is not ready. Whereas Zns loves to make a complex compound of coordination number 4. So ZnCl whole 4 2 minus. Sir, how would I know 4? Use a simple trick. If you have plus 1 oxidation state, coordination number 2, plus 2, coordination number 4, plus 3 and more, generally coordination number 6. Sometimes plus 2 can also have coordination number 6 as well, but mostly this logic will work for most of us. So Zn plus 2 is there, Zn shows plus 2, so ZnCl whole 4 will be made. So what happened here? This became aqueous solution. So as a result, what happened? Out of PbS and ZnS, ZnS is not ZnS anymore. He became ZnCl whole 4. It is not a sulfide. So only PbS left and can be froth floated. So here, who acted like a depressant? NaCl acted like a depressant. NaCl acted like a depressant for PbS or ZnS? He acted like a depressant for ZnS, allowing PbS to be the only sulfide ore in the mixture now, and zinc became ZnCl whole 4 2 minus. He is not a sulfide anymore. So happily you can froth float PbS from here. Apart from this, one more thing, little outside NCERT we can discuss here. Why not? Because most of you are going to be toppers in the NEET examination, and toppers need very good high level understanding. So sometimes I take a ore malachite. Now malachite ore is CuCO3 dot CuOH whole twice. I am taking this example so that you understand. This question was the NEET 2019 question. They directly asked you the formula of malachite. Sometimes as simple as this questions also come in the NEET exam. We have to prepare everything, including the easiest of the question also. So understand, if I ask you, can malachite be froth floated? The answer is no, at least not directly. So can you suggest a way so that malachite can be froth floated? I will suggest one way, and that way is called activator. So depressed one of the person, not allowing him to froth float. Activator will activate him and allow him to froth float. Understand now? तो भैया देखो यार, this is malachite. ठीक है? Now, if I react him with Na2S, the activator I am using here is Na2S. So what will happen? The upper surface will react with Na2S and will develop a coating over it. I'll show you. So this is malachite. It is malachite only. CuCO3 dot, I'll make it a little bigger. CuCO3 dot CuOH whole twice. It is malachite only, but just the surface, only the surface particle, they reacted with Na2S. Only the surface particle reacted with Na2S. And what happened when the surface particle reacted with Na2S here? So as soon as this surface particle react with Na2S, you got a coating of Cu2S on the top. So it is simple. It is just like you might have heard a lot of times that aluminium does not passive kinetically due to protective oxide layer formation. Here also what happened? The upper layer of malachite reacted with sulfide, formed a protective copper sulfide layer. Now, if you understand very well, I talked about common ion adsorption here because xanthate has a sulfide ion here. So what will happen? Because it has a sulfide ion here, so we understand very well that bhaiya, this bhai sahab will get stuck over any surface having a sulfide. So it's a surface phenomena. It does not matter what is inside. What matters is what is on the surface. So on the surface you have Cu2S. So will the xanthate stick like this, just like ZnS? The answer is 100% yes, it will stick. And what will happen? It will make him go up in the form of the froth. It can be extracted and dried. Then what you can do? Remove the upper surface by simply grinding, and you will have your malachite ore awesome out here with the froth flotation method. So what you did in the activator type? Nothing. This person was not able to do froth flotation because he was not a sulfide. We made him react with Na2S. So only the surface particle of copper became Cu2S, and now surface has sulfide. So xanthate will go will stick to him, will collect him and bring him out as a froth, and your ore will get concentrated, leaving the impurities down in the aqueous medium, and the ore will get separated in the form of the froth. You can dry the froth and get your substance, get your ore cleaned out or concentrated or dredged up or benefacted. These are the names given to concentration of ore. So now I'm going to discuss, I hope you understood this part. So in case you want to rewind and check, you can check again what I said. But now I will quickly move on to the leaching process. So let's start.